At night when we see at the sky, we see some little sparkling objects. Those we call stars. But what are they? And how they are formed? The stars.
Few hundred or thousands of stars we see twinkling in the night sky are just the tiny fractions of stars scattered throughout the universe. There are countless billions of them, and like our sun, they are all huge, fiery balls of gas.
How the stars are formed.
After the Big Bang, only hydrogen and helium atoms were formed. Due to their intermolecular force of attractions, they held together at places across the universe, forming huge shiny clouds of gas and dust. They are called nebulae. They are nursery of stars. This is the place where stars take birth.
After the Big Bang, the hydrogen, helium, and some traces of lithium and beryllium were formed, and these gases clumped together in space due to intermolecular force of attraction between them. So they formed a cloud, a cluster. These gases surround everywhere around the universe. There are some small portions where these gases collected, and due to the radiation from the Big Bang, they started glowing. These clouds of gas and dust which glows are called nebulae. These nebulae are nursery stars. It's a place where the star took birth. Nebulae, some atoms fuse together at the center point, and then a hazy sign produces due to the fusion of hydrogen into helium, and helium and hydrogen into lithium, and so on. It sucks all the gas in that particular portion of the nebulae and just carry out nuclear fusion in its core and grows in. It takes some million of years to grow to become a complete star, from protostar to small surrounded by clouds to a big giant star.
There are a variety of stars present across the universe. They vary in mass, spectrum and temperature, but how we classify them?
Basis of mass, temperature, and luminosity, stars are defined into following categories. Category number 1, 3 main sequence stars. These are the stars at very early stage of their life, that is the protostar when it just begin to born, or the very end stage of their life, that is a brown dwarf. So, second category, the main sequence stars. These are the main stars that actually completely develop and living its life. They are fusing hydrogen into helium in their cores, and that's their main fuel for life. So, the next, so they are red dwarf stars, yellow stars, orange stars, yellowish white star, blue white, and blue stars. So The red dwarf stars are smallest and coldest in temperature, while blue stars are the biggest and hottest stars. And third category is post main sequence stars. These stars are actually completed the term of life. Now they are dying. At the time of dying, with giant stars, the stars with greater mass turn into bigger stars like a yellow dwarf star or orange star. They turn into red giant, and some turn into red supergiant, and some turn into like white stars, blue stars, bluish white stars. They turn into blue giant or blue supergiant. These are 4 types of post main sequence stars. The real question is how we know. How do scientists identify what's the mass of star, what's its temperature, what's its luminosity, and all these things, because they are so far away from us, and really they don't appear as they are from far away from here on Earth or from telescopes that we had in our space. So there are various methods. They're really very easy. So first method is, in case of a binary star system where there are 2 or more stars orbiting a single star or each other, so we can calculate the relative velocity by just seeing them of the star revolving a star, and then we find out its mass and gravity, and then same of the other star around which it's revolving. In case of single star systems, we can use same method, or using same principle we can find out its mass, temperature, luminosity. And the main additional thing that now we have learned, that we can find every detail of star, every single detail of star, just by its color. Yeah, you heard it right, just by observing the color of light. Yeah, it's also a fact that universe is expanding, and the light from stars is red shifting or blue shifting. If they're moving far away from us, it's red shifting, and if it's moving closer to us, it's blue shifting. So we can calculate the amount of this red shift or blue shift, and now then we can find out what's its original color, and by a diagram called Hertzsprung-Russell's diagram, we can find out a star's temperature, its visual magnitude, and what is the spectral class that is determined in our visual color spectrum from purple to red. And there, when we see the color of star, and in that diagram we point out which is color spectrum ready, and there we can take its tell its temperature and its visual magnitude. From temperature and from their size we can find out its mass easily, and from this diagram even we can find out what this star is composed of by absorption spectrum of the star, because due to some elements they absorb some light of this color spectrum, like hydrogen absorb blue light and red light even, but there are different classes of hydrogen. Hydrogen alpha absorbs red light, hydrogen beta absorbs greenish blue light, and hydrogen gamma absorbs purple light. So by this we can know what an star is composed of.
Fate of the stars.
To determine the fate of stars, a Indian American mathematician and astrophysicist, Subramanian Chandrasekhar, defined a limit called Chandrasekhar limit, which is maximum mass of stable white dwarf star, which is 1.4 solar mass. It means it is 1.4 times of Sun's mass.
To predict the future of stars, we use this limit, gender limit or Chandrasekhar limit. So the this is the mass of a stable white dwarf star, that is 1.4 times of mass of our sun. So stars below this mass are called low mass stars, and stars above this mass is called massive stars or higher mass stars. So this stars, the low mass stars and high mass stars have same kind of life cycle. So in case of low mass stars, they end up simply by becoming a stellar nebula or white dwarf. So they all emerge from nebulae and become a protostar firstly, and then they go on to become a red giant. Then they become main sequence and red giant, then they turn into, then they lose their mass and they resist gravitational collapse, so they actually expanding their shells and then lose out in form of gases. They become the planet, now they become planetary nebula. So now when nebulas thrown away, expanded away from this body, the stars remain collapsed, core. It becomes a white dwarf, then it cools down its temperature, then become a brown dwarf, then a red dwarf, and suddenly fades away black completely, and it stops emitting light. Just remain a rock, a big giant small piece of rock roaming around in space. But in case of massive stars, their life future is extremely explosive.
Supernova, by releasing all its energy, matter, and mass. As shown in the life cycle of massive stars, they may have two different kind of endings. That means two different compact remnants. First of them is a neutron star, which is fastest spinning and it's very massive, by the way. Or secondly, they may become a black hole whose gravity is so immense that even light can't escape. To know more about this, hang on for next episode.
The stars are the one who created everything we see around us, including life. Because they have created all the elements that we are composed of. That's why they are called element factories of the universe. Also the reason why they say, we are made of stardust. If these stars didn't existed, even we may have not existed.